Welcome back to your next math lesson. This video is for Learning Target 3, starting on page 14. Go ahead and turn to page 14. Our learning target for today, we have two separate learning targets here. We're going to evaluate expressions that have a zero exponent, and then we're going to also evaluate expressions that have negative exponents. And keep in mind, you will not need a calculator today for majority of this lesson. You should be able to use this property without a calculator. Let's start with the zero exponent property here. This property says a to the 0th power is always going to equal 1, given that a doesn't equal 0. So the base number cannot equal 0. Any other number, if it's to the 0th power, it always equals 1. So if you give this a try after I delete this here, let's try the first one here, 5 to the 0th power. If you try it in a calculator here, 5 to the 0th power, it equals 1. Let's try the next one, negative 7 to the 0th power. So I'm going to put in parentheses, negative 7 to the 0th power also equals 1. It doesn't matter. Any number that's not a base of 0 is always going to equal 1. So if I try 5,000, just some random number here, and then to the 0th power, it equals 1. Okay? So these should be easy. 5 to the 0th power equals 1. Negative 7 to the 0th power equals 1. 2/3 to the 0th power equals 1. That means all of a sudden I get a base that's a variable, x to the 0th power. Well, that's going to equal 1. Let's take a look at an expression that has a number that has a 0 exponent. So I know 5 to the 0th power here equals 1 times, I know 5 squared equals 25. So all of this here equals 25. Next one, notice there's a plus sign here. So remember when there's a plus sign, these are like terms. Okay, so in our answer, we're going to have x to the 0th power because that's our like term, and then add the coefficients, 5 plus 2, which is 7. If we want to take this one step further, we know x to the 0th power equals 1. I still have a 7 in front of it. 7 times 1 is 7. Okay, so to finalize this exponent over on the left side here, a to the 0th power equals 1, assuming this base right here does not equal 0, okay, because you can't do 0 to the 0th power. So that one is a simple property. As long as you can remember anything to the 0th power, the exponent is 0, it's going to equal 1. Next property, our negative exponents property. So up until now, we've been dealing with only positive exponents. Now let's take a look at what happens when our exponent is negative. Okay? The statement I have here for negative exponents property is a negative exponent means that the number will equal a number between 0 and 1. So the misconception a lot of the time is anytime you see a negative exponent, people tend to think it's going to equal a negative number, which is not true. Remember, a negative exponent means it's going to equal a number between 0 and 1. So in other words, it's a really, really small number. Okay? So let's complete this table here so you can see a pattern on what happens with negative exponents. We're going to start with positive exponents, what you know, and then it's going to lead us to negative exponents. So in our table here, we're going to explore when the exponent is 4, 3, 2, all the way down to negative 4. And we're going to specifically do 2 to the nth power, and we're going to fill out the rest of these columns here. So let's start when n equals 4. So we're going to have 2 to the nth power, so this is going to be 2 to the 4th power. Okay? We're going to write 2 to the nth power as a decimal, which means it's as a number. So I know 2 to the 4th power, 2 times 2 times 2 times 2 is 16. Let's write 2 to the nth power as a fraction. So how do you write 16 as a fraction? Well, 16 over 1. And then 2 to the nth power as a positive exponent. Well, we already wrote it as a positive exponent right here because the 4 is positive, so we're just going to repeat 2 to the 4th power. Okay, let's do this with 3. 2 to the 3rd power, As a decimal, 2 times 2 times 2 is 8. Let's write 8 as a fraction, 8 over 1. And let's write this as a positive exponent, which is 2 to the third. So the rest should be, the next two rows should be simple to fill out. When n is 2, we have 2 squared. 2 squared equals 4. Write this as a fraction, which is 4 over 1. And write as a positive exponent, 2 squared. 1, so we get 2 to the first power, which equals 2. Write it as a fraction and as a positive exponent. Okay, what about when n equals 0? 2 to the 0th power. Remember, we just talked about this. An exponent of 0 will always equal 1. Okay, write this as a fraction, 1 over 1. Write it as a positive exponent. We're just going to write it as 2 to the 0th power. Okay, pattern continues. Now n equals -1. 2 to the negative first power. So you should have a calculator, or you can use the one on the computer. Let's type in 2 to the negative first power and see what it gives us as a decimal number. So 2 to the negative first power, it's going to give us 0.5. Remember, a negative exponent means it's a number between 0 and 1, and 0.5 is between 0 and 1. So here we go, 0.5. Let's write this number as a fraction. Well, we know 0.5 is the same thing as 1/2, 1 over 2. Next box here, write it as a positive exponent. So how do I write this piece as a positive exponent? Well, if I know the top number here is 1, and then I am going to rewrite 2 as an exponent here with a positive exponent, I know it's going to be 2 to the first power. Okay, you'll see a pattern here as we keep going here. Notice it's a positive exponent. These two are the same thing, because this equals half. This also equals half, because 2 to the first power is 2. Let's try n equals -2. So in our calculator, 2 to the -2 power equals 0.25. We should know that that is the same fraction, or that's equivalent to the fraction of 1/4. Let's write this as a positive exponent. So I'm going to have a 1 on top because it's 1/4. And to write 4 with an exponent would be 2 to the second power. Okay, how about -3? 2 to the -3 power. 2 to the -3 power equals 0.125. Well, 0.125 isn't the easiest fraction to remember, but take a look at this pattern here. Okay, when n was 1, we had 2 over 1, but when n was -1, we had 1 over 2. When n was 2, it was 4 over 1, but when n was -2, we had 1 over 4. So in other words, if n is 3 here in our exponent, and that equaled 8 over 1, well, we can expect then when n is -3 to -3 is most likely going to be 1/8. And you're going to notice 1/8 is the same thing as 0.125. See, if I do 1 divided by 8, that's 0.125. Okay, let's go ahead and complete this then. So this says a positive exponent is going to be 1 over 2 to the third power, because 2 to the third power equals 8, but it says a fraction because the 1 is on top. And again, you should be seeing a pattern here. You should see that 2 to the first power, opposite of that is -1, 1 over 2 to the first power. When n is 2, we have 2 squared. When n is -2, we have 1 over 2 to the second power. When n is 3, we have 2 to the third power. When n is -3, we have 1 over 2 to the third power. Okay, let's finish this up with -4 to the -4th power. So 2 to the -4th power equals 0.0625. 0.0625. Okay, the pattern here is when n was +4 is 16 over 1, so I can only assume this is going to be 1 over 16. Let's double check. Does 1 over 16 equal the same decimal? Yes, it does. You can see it matches. And then, as a positive exponent, it's going to be 1 over 2 to the 4th power. Okay? So, again, to remind you, a negative exponent means that it always is going to equal a number between 0 and 1. Notice these negative exponents. Notice they equal numbers less than 1, but bigger than 0. They're not negative. So, what does this property look like? Well, let's complete it. Basically, it says this. A to the negative n power is equivalent in positive exponents as 1 over a to the positive n exponent. So basically, you're writing it as a fraction, and all of a sudden the exponent becomes positive. Likewise, if you have 1 over a to the n, that's the same thing as saying this is going to be a small number. You know it's going to have a negative exponent because it's a number less than 1 but bigger than 0. Okay, so these are just swapped here. So let's give a few problems a try then. It says write the expression as a fraction with no exponents. Okay, so I want no exponents, and I want it as a fraction. So you can't just go into your calculator and type in 5 to the negative 3rd power because it's going to give it to you as a decimal. I want your answer as a fraction that has no exponents in it. So following this property right here, a to negative n, I know I can rewrite it as a fraction as 1 over a to the positive n. So this is going to become 1 over 5 to the positive 3rd power. And because I don't want any exponents in my answer, I'm going to do 5 to the 3rd power in my calculator and keep this part as a fraction. And I know 5 to the 3rd power then is 125. So 5 negative 3rd power is 1 over 125. How about 4 to the negative 1? That's the same thing as saying 1 over 4 to the 1st power, which is the same thing as saying 1 over 4, because 4 to the 1st power is just 4. So this, you know, right here is 0.25. This also is 0.25. You can try it in your calculator. And last one, t to the negative 6. I want it as a fraction. So I know this is 1 over t to the 6th power because I put in a fraction, now the exponent is positive. But this one you can't rewrite with no exponents because you can't do t to the 6th power. Well, I guess you could. You could do it this way. Let's get rid of the exponent. So there are 6 t's being multiplied. So 1, 2, 3, 4, 5, 6. There you go. You just wrote your answer with no exponents and as a fraction. Okay, let's try the other side. Write the expression with a negative exponent. So I want you to rewrite this with a negative exponent. So I know if I rewrote this with a exponent to start with, I'm going to have 1 over, and I have 6 times 6, which is the same thing as 6 squared. Well, if I want a negative exponent, this property right here, I know 1 over a to the positive n is the same thing as saying a to the negative n. So this right here is the same thing as saying 6 to the negative 2nd power. Okay? Next one, same thing. 1 over 1, 2, 3, 4. So this is 8 to the 4th power because there's 4 8s being multiplied. This is equivalent to 8 to the negative 4th power. It's a fractional number here. And last one, 1 over 1, 2, 3, 4, 5, 6 a's here in the 6th power. I want it as a negative exponent, so I know this is equivalent because it's a fraction to a to the negative 6th power. Okay? So if you get lost anywhere there, make sure you're pausing and asking questions. Otherwise, go ahead and turn to the next page. Okay, let's look at our last 4 problems here. Our last 4 problems are multiple property problems. In other words, you have about 7 properties that you should know by now. Okay, and all these problems could be using any of those 7 properties. So have a list of those properties out and see if you can apply them. So let's take a look at the first one here. Simplify each expression, write your answer using only positive exponents. So in all your answers here, you should only have positive exponents, okay? All right, first one says 2 to the negative fourth power times 2 to the second power. Well, notice we have like bases, and we're multiplying. So remember that rule. We're going to add the exponents here. Okay, so I'm going to end up with 2 as my base, and negative 4 plus 2 is negative 2. So I added the exponents. Okay. Okay. Positive exponent. So I know 2 to the negative 2 power, our new property here, is the same thing as saying 1 over 2 to the second power. And then we could stop there because it has a positive exponent. Then we carry this one step further if we wanted to. I would count this correct because it's following the directions as positive exponents only. But we know that 2 squared is 4, so final answer here is 1/4. And if you type in 2 to the negative second power in your calculator, 2 to the negative second power, it's going to equal 0.25, which is the same thing as 1/4. Second one, so we've got a fraction here. And in our fraction, we have some number pieces and we have some variable pieces with exponents. Okay, so this is the same thing as saying 5 times x to the third divided by 10 times x to the seventh. Okay, so we know we're going to use a quotient property here because we have a fraction bar. Let's start with the number pieces. 5/10. Well, 5/10 can be reduced to 1 over 2. Okay, divide each the top and bottom by 5. We're going to end up with 1/2. Times, now let's do the variable pieces. Well, I have x to the third on top and x to the seventh on the bottom of the fraction. Remember the rule, what do we do with like bases when we divide? We subtract the exponents. Okay, top minus the bottom. So we're going to end up with base of x, 3 minus 7 is negative 4. Okay, so we're not done yet because we want positive exponents only. So we're going to keep 1/2 as 1/2. Remember x negative fourth, our new negative exponent property. This is the same thing as saying 1 over x to the fourth power. And let's go ahead and just simplify. Multiply fractions. So we're going to do multiply top by top, bottom by bottom. 1 times 1 is 1. 2 times x to the fourth is just 2 times x to the fourth. Final answer here is 1 over 2x to the fourth power. Next one, 3 times 4 times c in parentheses and all to the negative second power. So remember the the property where we have an exponent on the outside of a set of parentheses, we're going to give that exponent to each factor inside. So I'm going to keep this 3 by itself times 4, it gets a negative 2 exponent, times the c also gets a negative 2 exponent. Okay, so we have 3 pieces here total. We don't want any negative exponents, so let's change these here. So my 3 here is going to stay a 3, but I'm going to make it a fraction, and you'll see why. So 3 over 1 is the same thing as 3, times 4 to the negative second power. Using our new property, we know this is the same thing as saying 1 over 4 to the positive second power, times c to negative 2 power is the same thing as saying 1 over c to the positive second power. So now we have 3 fractions being multiplied together. Let's just multiply top pieces all together here. So 3 times 1 is 3. Bottom number, 1 times 4 squared times c squared. So I know my answer is going to have a c squared in it, and I know this 1 doesn't matter. And 4 squared here, 4 times 4 is 16. So final answer is 3 over 16 times c squared. Last one. Well, we have x to the negative first power. Stays out there. Then we've got 3x inside the parentheses. Let's give this negative 3 to each piece inside. So we're going to get 3 to the negative third power times x to the negative third power. So we have 3 pieces here. Let's rewrite these with positive exponents. So x to the negative 1 is the same thing as 1 over x to the first power, times 3 to the negative third power is the same thing as 1 over 3 to the positive third power. And x to the negative third is the same thing as 1 over x to the positive third power. So again, we're using our new property, our new negative exponent property. Okay, let's multiply all the top pieces. 1 times 1 times 1 is 1, fraction bar. All the bottom pieces here, well, let's do the number piece. 3 to the third power, 3 times 3, which is 9, times another 3 is 27. And then we have x to the first and x to the third. So we have 1x here and 3x's here. Add the exponents. We're going to end up with x to the fourth. And we're going to end up with an answer of 1 over 27x to the fourth. All right. If you need to re-listen to that, pause it, rewind, and take a look at it again. Let's close with a summary. 3 properties we learned today. Actually, just 2 properties. First property was the easiest. Anything to the 0th power always equals a big fat 1. Negative exponent property says a to negative n is the same thing as saying 1 over a to the positive n exponent. Remember, it's just a fractional number. It's still positive. It's just between 0 and 1. Likewise, these two are related. 1 over a to the n, fractional number, is the same thing as saying a to the negative n power. All right. Go ahead and get started on your classwork. Make sure you ask some questions. Good luck.